show you where the X and Y axis is. It's kind of assuming that you know it's there. So we're going to put in an X and Y axis. So they're going to be like the diameters of our circle that are marked. So I would put in, let me make sure it's going to rain black first. Okay, this line right here, hopefully you can draw straighter than I do. This is also the same as far as when you're talking about coordinates as having your y-axis, because the circle's kind of centered in the middle of the coordinate plane like we talked about yesterday. And then your x-axis would be going across here. So if you're not super strong with like x, y axis, you need to remember you might want to mark those more prevalently in your diagram here so you understand how you're using that circle on a coordinate plane. The second thing that we talked about yesterday, remember how we filled in the charts? And what we kind of came to the determination was we kept getting the same answer, so that even if the triangle was big or if the triangle was small, the sine of 30 kept coming out to be 1/2 every single time. And we said that means that we can make the triangles however large we want, but our sine, cosine, and tangent calculations will always work out the same. So if mathematicians wanted to make something to organize the sine, cosine, and tangent calculations, it didn't matter how large they made it. And we said that's why they picked the unit circle. Okay, the unit circle means the radius is equal to 1. Okay. So think about what that means as far as some of the points here on the circle. Just knowing that definition immediately lets you identify some of the points. For example, this point right here. If this point is on the circle and the circle has a radius of 1 unit, meaning you know from the center to the edge of the circle is a distance of 1, what would you tell somebody are the coordinates to land at this same point on the XY axis? 1, 0, because the radius of the circle is 1, right? So if I want you to land right here, I want you to go over 1 on the x, but I don't want you to go up or down any on the y-axis. So the coordinates at this point are 1, 0. Okay? I'm going to zoom it in now that you guys kind of know which part of the circle I'm talking about, so you can see a little bit better. What about if I wanted you to go up here to this top point at the circle? What would the coordinates be there? 0, 1. No left and right movement, but 1 point up. That would be 0, 1. Okay? What about if I wanted you to land over on the side of the circle, but on the left side rather than the right side? Good. -1, 0. And this is why it's helpful to put the circle on the coordinate plane, the XY axis. Because before, if I said, oh, I want you to just go out like to the side of the circle, you'd be like left side or right side. But now you know where you're supposed to land. If I say +1, 0, you know you're supposed to be here. Versus if I say -1, 0, you know you're supposed to be on this side. But we couldn't do that if we didn't have the XY axis with our circle. Is that okay with everybody? Now what I want us to do is I want us to name these positions on the circle, like pretend like the XY axis isn't there. What degree measurements are these on the circle? Now for us to determine that, we all have to start at the same point, right? If I said, oh, go 90 degrees along the circle, you might all do it, but we might all end up in different places if we didn't start at the same place. So mathematicians, when they designed this, had to decide, here's where we're going to call 0. Like they had to make the beginning. So the positive x-axis is the beginning. So this right here is your 0 degree location. Okay, so everything is measured from here, and we tend to go counterclockwise around the circle. It seems weird, but mathematically it doesn't seem weird, because if you guys remember, the way they name the quadrants, when you graph, that's quadrant 1, and then this is quadrant 2. And then this down here is quadrant 3. I don't know if you guys remember the names of these quadrants from like Algebra 1 when you first started graphing. Notice the direction the quadrants go is the same direction we'll go around the circle, from 1 through 2 through 3 through 4. Is that okay with everybody? All right, so now if we're thinking in terms of degrees on a circle instead of XY coordinates, this is 0 degrees. If we go this way, how many degrees is this position up here that with coordinates we said was 0, 1? If you didn't want to tell someone X and Y coordinates and you wanted to tell them how many degrees to go around the circle, how many degrees would you have gone to arrive at this point up here? 90, okay? So the degree marker here is 90. And what would the degree marker be over here at this position that was described with -1, 0? 180. Is that okay with everyone? All right. So the next thing we want to do is we want to mark what these angles are in here. And honestly, if we didn't know what our end goal was, it would be ridiculous. Like if I just laid this in front of you one day and been like, you should know how many degrees these are right here, you'd be like, I need a protractor. I don't know how many degrees they are. But remember, we don't have to learn every angle. The unit circle doesn't have every sine, cosine, and tangent on it. It only has the angles that are in special right triangles, right? So what were the degrees of the angles in our special right triangles? 90, we already got that. What were the other angle measurements? 30s and 60s in one kind of special triangle, or 45s in the other. We are only focusing on things that are either 30 degrees away from the x-axis, 60 degrees away from the x-axis, or 45 degrees away from the x-axis. So knowing that those are the only three numbers I care about that are smaller than 90, notice there's only 3 lines in this organizing tool here for less than 90. These 3 lines are supposed to be for the 30, the 45, and the 60. Okay, and if we're measuring from here, the smallest angle that I just said out of my mouth was the 30. So this first one would be the 30. Okay. The next one would be the 45, and that kind of makes sense because it's right in the middle of the 90 degrees. And then the next one would be 60. Is that okay with everyone? All right, now the circle enables us to do more than what we used to do with triangles. Like in your calculator, in a triangle, if we tried to do sine of 120, that wouldn't make sense because you can't have a right triangle that also has a 120 degree angle in it, right? Okay. But in your calculator, can you type in sine of 120 and get an answer, or cosine? You guys have done cosine when you're doing log cosines of things like 240, like big stuff, right? Okay, maybe that you ended up with. We can go past, okay, 180. This is what the circle enables us to do. It allows us to take those triangles and make a bigger world of trigonometry, but using all the same information from the triangles, okay? So our focus here is going to be, what are the other angles that are like 30? In other words, what are other things that are 30 degrees away from the x-axis? So over here, here's another angle. It's also 30 degrees away from the x-axis, okay? But I wouldn't call it 30 because my measurements are saying how far it is from here. Okay, so even though this is 30 degrees from the x-axis, how far is it from 0 to go all the way over to this angle over here? 150, because it's 30 degrees away from completing the half circle of 180. So this would be 150. Okay, so that's one way to look at it. Okay. Another way to look at it is you can actually count around the circle by different amounts. Okay. 30s and 60s are super related. Like if I go and I count around the circle by 30-degree chunks, that means from here to here, that's 30 degrees, right? If I add another 30 to that, I skip over the 45. The 45 is like a different animal than the 30s and 60s, just like the triangles, right? 30s and 60s were in the same triangle together. 45s had a totally different pattern, okay? So there's 30. 30 plus another 30 would give me 60. 60 plus another 30 would give me 90. 90 plus another 30 would give me 120. So this angle here is 120. 120 plus another 30 would give me 150. 150 plus another 30 would give me 180. So I can actually hit everything that's 30 or 60 degrees away from the x-axis, because 60 is a multiple of 30, by counting around by 30s. But I better be careful and skip my 45s because they're like in a different world, right? Like it'd be nice to have them in different colors or something. They're very not related to each other. They just got put on the same circle, okay? We could do the same thing and count around by 45 separately if you wanted, like 30 and 60s kind of exist in one world and 45s in another. If I count by 45s, if I go from 0 and add 45, I would land at 45. 45 plus another 45 would be 90. 90 plus another 45 would be 135. And 135 plus another 45 would be 180, okay? So are you guys starting to feel comfortable with one? We're only marking things that are 30, 45, or 60 degrees away from the x-axis, but these ones are not 30 degrees away from here. They're 30 degrees away from this x-axis. And below, like there's one right here, it's 30 degrees below the x-axis. And there's another one that's 30 degrees below the x-axis here, okay? And then what we did yesterday, this looks a little like we did yesterday, but more complicated. You know how yesterday we just put one triangle, but it had the XY axis with the circle on it? And yesterday what we did is we said, okay, if you want to name this point right here, there's a triangle. You guys don't have to draw the triangle because you just need the info. I just want you to relate it to what we did yesterday, so I'm going to draw it for you here. That this is a 30, 60, 90. If this position is 30 degrees away from here, that angle is 30 degrees. If I connect these two together, I know the grid lines for the XY axis make a right angle. This made a 30, 60, 90 degree triangle. And remember that your hypotenuse is 1 in your triangle because it's the radius of the circle, and the circle the mathematicians picked would have a radius of 1. And then remember, we did the work yesterday. It was on the back of that classwork 2 handout. We summarized it, and then we wrote it right on the handout just like this, that if that's 1, we did the math, we worked backwards and divided by 2 and then times it by rad 3. That 1/2 and rad 3 over 2 had to be the lengths of the sides of this triangle. So if I want someone to land at this point, there's 2 ways right now for me to give them enough information to get there. One way is in circle language. Go 30 degrees around the circle, and they would land right here, right? The second way is in coordinate plane language, the way we normally plot points on a graph. And in order to get them at that same place, I would have to tell them to go to the right, rad 3 over 2, and then up 1/2, meaning I want the x coordinate to be a positive rad 3 over 2, and the y coordinate to be a positive 1/2. Okay, this is what we did yesterday, but there was only one triangle in the picture with the circle. Okay, we separated the 30, the 60, and the 45. Here we're putting them all together in the same place. Okay. Then if you guys remember when we looked at the 60, the 30 and the 60 kept getting grouped together because they had the same info. So if we did the same thing for this 60 degree location, and again, you guys don't have to draw in all the triangles because it would get messy for you, but I just want you to remember where it came from. We said this is 60 degrees, this angle in here. If this is 60 degrees, this is still a 30, 60, 90 triangle. So I still have all the exact same numbers because it's the same triangle, but it's been kind of like positioned a different way. And when it was positioned the different way, the hypotenuse is still 1, but now this is the 1/2 and this is the rad 3 over 2. So if I want someone to land at this spot, again, 2 ways for me to tell them. In circle language, I would tell them go to the 60 degree location. In coordinate plane language, I would need to tell them go to the right 1/2 and then go up rad 3 over 2. So the coordinates at the 60 would be 1/2 and rad 3 over 2. Same numbers as the 30, but different ways because the short part of the triangle was in a different spot. Here, the short part of the triangle was the y coordinate, so that's why you see the 1/2 there. Here, the short side of the triangle was the x coordinate, and that's why that number was in a different place in that coordinate. Okay? And then we also did the 45, 45, 90. Again, it's kind of way separate from the 30s and the 60s, and you don't have to draw the triangle. Just going to do it to show you on here. So yesterday, we had one triangle in the circle and said, okay, if this is a 45 degree angle here, so in circle speak, if I want someone to land here, I say go 45 degrees on the unit circle. They land there. In coordinate plane, what do these numbers have to be? So yesterday we solved that if it was a 45, 45, 90, and we knew the hypotenuse was 1, we worked backwards and did all the dividing by rad 2 and all of that kind of stuff, and we got that these lengths would be rad 2 over 2. So in coordinate plane, in x and y coordinates to get someone to this location, I would tell them go to the right rad 2 over 2 and then go up rad 2 over 2. Okay, so the coordinates here for this 45 would be rad 2 over 2, rad 2 over 2. The 45s are nice because they have the same x and y distance, okay? But they are not nice when you look at a 30 or a 60. They're totally different than the 30s or 60s, right? These two, 30 and 60, they have like the same kind of stuff going on. 45 is like a whole different world. Just like when we counted around the circle. When we counted by 30s, we hit the 30s and the 60s. They skipped the 45s, different relationship, okay? So what I want you guys to try right now is I want you to try at every position that's marked on this circle to mark what degree measurement you think it should be named with. So we already went from 0 to 180, but there's from 180 to the end. The end would be one lap around the circle. And do you guys remember how many degrees are in a circle? 360. So this right here is 360. In other words, if someone says go to 0 degrees on the circle and they tell someone else go to 360 degrees on the circle, me and the person they talk to land at the same place because 0 and 360 are technically at the same position on the circle. Okay, the other person just did a lot more walking than I did. I didn't go anywhere. Okay, they walked all the way around to get there. But you guys should now fill in all of these angle degrees up to 360. And then I want to see if you guys can also fill in the coordinates, and I'll give you one hint as far as how to do it. I'll do one with you. I'll work on 150 with you. So to me, remember how I drew these little triangles in here? Here's the triangle at the 30-degree angle. If I take that triangle and I flip it over, that triangle will fit perfectly right here at the 150-degree angle marker. Is that okay with everybody? Can you see that if I reflect it? Now, did I change the size of the triangle when I reflected it over? No. So we already knew in this triangle that the x was rad 3 over 2 and the y was 1/2. So if I take it and I just go like this distance is still rad 3 over 2, and this distance is still 1/2. But what's the difference on the coordinate plane? How do I end up over there instead of over here when I'm writing points? How do you get somebody to plot a point in the first quadrant versus the second quadrant? Izzy? Negative. Good. If I want them to land over there, I don't want to change the distance, but I want them to understand they had to go left instead of right. And so the coordinates here would be negative rad 3 over 2, 1/2. That would tell them go left rad 3 over 2 and up 1/2. So 30 and 150 almost have the same information because they share the fact that they're 30 degrees away from the x-axis. But being in the second quadrant gives it a negative x coordinate. Is that okay with everybody? So your goal now is to use the information we have here about 30s, 45s, and 60s to fill in the rest of the degree measurements and try to fill in all of the coordinates that are on there. Okay, so you guys should have, okay, I'm not talking about positives and negatives right now. Okay, I'm just talking about the number part, okay? You should have the same x and the same y for these 4 angles. Okay, all 4 of the angles I've highlighted, so that would be at 30, 150, 210, and 330, they should all have a rad 3 over 2 in the x and a 1/2 in the y. Okay? Those are all 30 degrees away from the x-axis. They would all be the same triangle, just flipped over one of the axes to make the other angle. Okay? You should then have like numbers, but in a different order, for these 4 angles. So at 60, 120, 240, and 300, you should have a 1/2 in the x-coordinate and a rad 3 over 2 in the y-coordinate for all of those. I'll talk about if they're negative or positive in a minute. But so all the things I've highlighted in green, 60, 120, 240, 300, you should have a 1/2 in the x-coordinate and a rad 3 over 2 in the y-coordinate because those are all 60 degrees away from the axis. Okay? You should have the same coordinates for all of the 45s, which I've highlighted in blue. So those angle numbers should be 45, 135, 225, and 315. All of those should have rad 2 over 2 as the x-coordinate and also the y-coordinate. Okay? Now, everything that's in your first quadrant, that was the first one that we did together, should have a positive x and a positive y, because that's how you plot a point in that quadrant, okay? Everything that's in your second quadrant, everything over here, should have a negative x, but a positive y. That's how you would plot a point in the second quadrant. Everything that's plotted in the third quadrant, down here, should have a negative x and a negative y. That's how you would plot a point in the third quadrant. Okay. Everything in the fourth quadrant over here on the lower right-hand corner should have a positive x, but then a negative y. Is this all right with everybody? So I have this information memorized. That is not my expectation of you. You're going to get this tool when we take a quiz next week that's going to involve the unit circle. But you have to know how to use the tool. If you have no idea how to use this tool, you're right where you're supposed to be. All we've tried to do is understand how the tool was put together. So all we should know right now is that there's a coordinate plane and a circle. And to get to these points, you could either tell people an amount of degrees or an x and y coordinate. And how we knew that this x and y coordinate matched that degrees came from your special right triangle stuff. That's all you have to know right now, okay? If someone asks me, like, what's the sine of 280 degrees? I don't know. You know why I don't know? Because 280 degrees is not an angle that I'm supposed to know something about. We don't use it that often. But if somebody asks me the sine of 270 degrees or 240 degrees, I know those because I have this idea, this whole thing I have in my head, okay? As you can see, if you're a person that's going to have to memorize it in the future, you do not memorize all of these little pieces of information. What you do is you learn these ones really well, and then you just understand how to get the other ones. That's how people memorize this. They don't try to memorize like 20, 30, 40, 50 pieces of information randomly, okay? They try to memorize a few pieces and understand how it would go around the whole circle. That's a tip for those of you that do have to take a trig or a pre-calc or a business calculus or something like that in your future, where you will have to know some of this, okay? There is one empty line at each of your angles. We're going to learn that on Friday, okay? There are two ways to name angles. You know how your calculator has two modes for your angles? We like it in degree mode, but the other mode is called radians. All of these degree measurements could also be spoken in the units of radians instead, and we have to know those as well. So tomorrow you'll take your quiz. There will be a set amount of time because it'll be just like the warm-up, so it should be fairly quick. Afterwards, we're going to try and use this tool with only degrees. Okay? How do you find sines, cosines, and tangents with this thing? How does it possibly help you? We're going to figure that out, and then on Friday we'll label the radians and practice the same idea with them. Okay? And that's kind of like the last thing we're doing for the semester. We'll practice it next week. We'll work on it and get prepared for our final. Okay?